Sample and holds are devices that are basically used in analog to digital converter, where we have analog signal and we want to find out its corresponding digital value. Suppose you have a sample analog signal xt and it is a continuous time signal. It means it has been defined at every instant of time. We first have to convert it into a discrete time signal, and we take the sample at different instant of time, and depending upon at that value of time what's the amplitude, and we basically it later state convert into binary code. So to find out the amplitude at particular instant of time, this is where sample and hold circuit are come into the picture, where we want to know what's the value or what's the voltage level or signal level at that value. For this, the best way or simplest way is to use a capacitor, where let's say we have a capacitor ch and it is connected through a switch to an input voltage. So when switch is closed, so basically in that case it will input signal, it will charge the capacitor ch, and in that case the the voltage output voltage will be equal to input voltage, basically following the input voltage. In this mode it is also called tracking mode as well. And when we have this switch off, the switch is open, then the whatever the value of the voltage that was there when the switch was closed, it hold that value, and the even the our input will change, the output will remain that particular instant of value. Let's say if it is V1, at the moment the voltage was V1 when we open the switch, so it will hold that value. Now let's further understand it in the form of waveform. Let's say we have a continuous amp signal, let's say xt, which varying as a time increases as a function of time. Then we have a second signal which is called control signal. It is basically a signal that will be used to switch, to close and open the switching. The switch that is connected to open or close is controlled by this signal that we call V control. This can be MOSFET, BJT, or whatever we want to use as per the requirement. And the third is the what will be the output voltage. Now let's consider when the, let's say when the V control is at high, is that time the switch is closed. So, and when the V control voltage is low, the switch is open. The switch was closed, in that case it was sampling, so it was following its input. And when it was hold, when the switch was open, when in the hold stage, so it will hold that particular sample value, and then again it will come the sample value s, then it will again start following the input signal, and when it is hold, it hold that particular value, and then again it will come sample, then it will again start following that value. Now there are certain associated advantages and disadvantages with this basic circuit when we have only capacitor. First is that if let's say input side has very high impedance, in that case while it is charging, so RC time constant will increase, so it will be very slow, it will not charge very fast. So this is an issue. At the same time, if the output side has a low impedance, in that case when it is holding this during the hold period, then it will not see very high impedance, so it will discharge. So basically the low if the low impedance is there, then RC time constant is low, so it will discharge very easily. So it is opposite. So basically at input side we want a very low impedance, so that if RC time constant is low, it can charge very fast and follow input values of the voltage. And when it is high, at the output side we want very high impedance, so that when it is holding it should not discharge, so as time constant should be high. So we need something which provide at one side very high impedance and other side very low impedance. So this is where we use op amps, because op amps has very high input impedance and very low output impedance. Now if we connect this into in an op amp circuit, this is where we can connect this our structure. Here the switch has been replaced with the MOSFET, where D and S are source and G is gate, and we are applying this voltage control signal to the gate to closing and to switching on and off the MOSFET. And on the input side we are connecting with a unity follower, unity gain or voltage follower op amp. So since op amp has low output resistance, so the capacitor through switch is seeing very low impedance, while at the same time on the output side it is seeing the input side of an op amp, so which has very high impedance. So this way it is follow, it overcome those limitations. Now when the control signal is high, basically on, so the op amp will be now first op amp will be directly connected, switch will be closed, so op amp first will be directly connected to the capacitor ch, and then input voltage voltage will pass through the MOSFET, and capacitor ch will charge, and in its follow whatever the input voltage is there. Now if control signal is low, or then in that case the switch will be off and the capacitor and it will basically disconnect. Now the capacitor will see very high input impedance of the op amp 2. So it will not discharge and it will hold that value. So this kind of a configuration is called open loop configuration of sample and hold circuitry with operation amplifier. The advantage or is that it is fast, very fast, while at the same time the advantage is that if there is an DC offset in the op amp it will add up, so there is a DC offset error that is present. To overcome this we use closed loop configuration of sample and hold circuitry. The closed loop circuitry, this is shown here, where now the second op amp is now is has a feedback which is taking output voltage to its input voltage. This is configuration is called closed loop configuration. Thing is same as the previous one, it's just that the feedback is there. So this overcome the issue of DC offset error, but it is at the same time it is little slower. It is more accurate, but it is little slower as compared to the open loop configuration. It is fast, but not as fast as for the open loop configuration. It is there, but it is has good accuracy. The another configuration of further improvement in this structure is that we can connect this capacitor to the feedback of second op amp. This way what is we solve is that the capacitor is connected to the source of the MOSFET is now connected to the virtual ground of op amp 2. So so source will see a virtual ground, and this way leakage current that are there in MOSFET circuitry is comparatively low as compared to the previous configuration. This is one of the advantage of using capacitor as the feedback. Here if you notice the open polarity has been changed. Earlier we input was at the positive or non-inverting terminal of op amp 1. Now it is has been fed into the inverting terminal of op amp 1.